When right-sizing resources, 14-day lookback periods may miss monthly utilization patterns like month-end processing spikes, leading to suboptimal recommendations that can increase costs or degrade performance. You can now extend the lookback period to 32 days for EBS volume and ECS service recommendations in AWS Compute Optimizer at no additional cost. You capture monthly utilization patterns by analyzing a full month of data, enabling more informed right-sizing decisions. You set the 32-day lookback period at the organization, account, or resource level through the console, AWS SDK, or AWS CLI. You apply this extended lookback to 5 resource types: EC2 instances, EC2 auto-scaling groups, RDS databases, EBS volumes, and ECS services. This feature is available in all AWS regions where Compute Optimizer operates, except AWS GovCloud US and China regions. Data analysts and data scientists often lose context when switching between analytical sessions, forcing them to rebuild context and regenerate code. SageMaker Data Agent Conversation History solves this by preserving your analytical workflow across sessions. You can access past conversations through the clock icon in the chat panel header, with each conversation automatically titled and timestamped for identification. You can reference previous agent-generated code without regenerating it, resume multi-step analyses exactly where you stopped, and review past troubleshooting interactions from earlier notebook runs. The feature maintains context across notebooks and query editor workflows, enabling you to work on concurrent projects without rework. Conversation history is available in all AWS regions where SageMaker Data Agent operates. When you run multi-region applications with Aurora or Neptune global databases, failover requires manual intervention that adds critical minutes to recovery time. For Aurora active-passive configurations, you must manually right-size and scale your secondary cluster before it can handle production traffic. For Neptune global databases, you must script or manually decide between switchover and detach and promote operations during an incident. ARC Region Switch now provides 3 execution blocks to automate these operations. You can automate Aurora serverless scaling to right-size your secondary cluster as part of the region switch plan. You can automate Aurora provision cluster scaling to ensure your secondary is ready for production traffic when failover completes. You can automate Neptune Global Database failover to handle both planned switchover and unplanned failover scenarios within a single plan. All 3 blocks support cross-account orchestration, allowing you to coordinate database operations across multiple accounts and regions in a single plan. When managing IoT device fleets, you need to troubleshoot connectivity issues and audit connection patterns, but historical connection data has been limited. The Connectivity Status API now provides full visibility into device connections. You can retrieve MQTT session timeout and expiry values to understand session behavior. You can access socket details with IAM policy controls to restrict sensitive information to authorized teams. You can store connection data indefinitely after disconnect, unlike the 30-minute retention of the Get Connection API, enabling investigation of issues long after devices go offline. You can query device connection info by thing name to access connection status, timestamps, disconnect reasons, source and destination IP addresses, ports, and VPC endpoint IDs for devices registered in the IoT Core Thing Registry. Building workflows that incorporate AI reasoning tasks like document classification or data extraction typically requires you to manage agent infrastructure and orchestration logic separately from your workflow code. Step Functions now integrates with Amazon Bedrock AgentCore harness to address this. You can integrate AI agent reasoning into workflow steps by declaring agents through configuration with specified models, tools, and behavior. You can run multiple agents in parallel or sequence at different decision points, enabling complex multi-agent workflows with human approval gates before critical actions. You can trace agent decisions with execution history that shows input, output, token usage, and duration with links to CloudWatch for auditing. You can override agent configurations per invocation including model, system prompt, and tools, allowing you to adapt agents to each workflow context without duplicating configurations. Agent context persists across invocations using session IDs. Training models to power agents that complete multi-step tasks requires custom infrastructure that takes weeks to build and is complex to operate. You need to orchestrate rollouts, collect trajectories, manage checkpoints, and evaluate model performance across sequential decision-making tasks. SageMaker AI multi-turn reinforcement learning addresses this by providing a serverless solution. You can train models on multi-step agent tasks without provisioning infrastructure, connecting your agents from Amazon Bedrock AgentCore, Runtime, Amazon EKS, EC2, Fargate, or custom environments. The service manages the full training loop including rollout orchestration and trajectory collection. You can track trajectories and evaluate models using built-in ML flow tracking and evaluation jobs that report reward, pass at K, and trajectory metrics before deployment. You pay only per token process with no infrastructure to manage, enabling you to specialize smaller models to match larger model accuracy on your workloads. When consuming CDC streams from Amazon Keyspaces tables, you previously had to poll at a fixed cadence regardless of whether new records were available. This approach resulted in inefficient resource usage and unnecessary CDC consumption costs. You can now use the iterator position feature to optimize your polling strategy. You can check the iterator position in the getRecords response to identify whether the stream status is at _TIP or behind _TIP. You can adapt your polling frequency based on this position, polling more frequently when records are pending and reducing polling when at the tip of the stream. You can reduce CDC consumption costs through this optimization while maintaining timely data processing for your data integration pipelines and event-driven architectures. The getRecords response includes an iterator description structure with an iterator position field that enables this functionality. You need to update to the latest AWS SDK to use this feature. Moving notebooks from experimentation to production requires orchestrating recurring workloads like daily reports, data quality checks, and model retraining, but managing external orchestration infrastructure adds complexity. You can now schedule and parameterize notebook runs directly from the SageMaker Unified Studio interface without external tools. You can trigger on-demand background runs on dedicated compute without interrupting your interactive sessions and create scheduled or recurring runs. With parameterization, you can reuse a single notebook across different inputs by defining parameters and overriding values per run. You can chain multiple notebooks into workflows using the notebook operator in the Workflows tool, where outputs from one notebook feed as inputs to the next. When runs fail, the SageMaker Data Agent provides AI-assisted troubleshooting to identify root causes and suggest fixes directly in the notebook. You can also use the Data Agent to create schedules and start runs using natural language commands. When managing IoT device fleets, you need visibility into connectivity problems and authentication failures to maintain reliable operations. Without detailed logging, diagnosing why devices disconnect or fail to authenticate requires time-consuming investigation. AWS IoT Core now provides 2 CloudWatch log event types to address these challenges. You can monitor MQTT keep alive messages with ping log events to identify devices that cannot maintain connections. You can track authentication failures with connection.auth logs that include detailed error codes, enabling faster resolution of credential and certificate problems. You can view detailed error codes for credential issues directly in the logs, reducing troubleshooting time. To use these capabilities, you configure event-level logging in IoT Core settings by specifying your log level and CloudWatch log group destination, then opt into the new event types. These logs are available across all AWS regions where IoT Core operates. Developing and testing DB2 applications traditionally requires commercial software licenses, creating cost barriers for non-production environments. Amazon RDS for DB2 now supports IBM DB2 v12.1, including standard, advanced, and community editions. You can deploy DB2 v12.1 on RDS with a managed service that handles database operations. You can access all standard and advanced edition features through Community Edition. You can eliminate licensing costs for development and test workloads since Community Edition includes no commercial software charges. You can create instances across all regions where RDS for DB2 is available. To get started, obtain a free IBM Customer ID and launch your database instances through the RDS console.